we go. Okay, we're good. Today we are naming compounds. I guess we're writing formulas too, but we'll just say naming. Or you can just write compounds with polyatomic ions. So today, our anion could be polyatomic. When you hear the word poly, what does the prefix poly mean? We talked about this. Poly is, right. So far we've been just doing binary compounds, which have had how many elements? 2. So now we're going to be having more than 2. Okay? So more than 2, there's not a lot of background for this. We're going to jump right into formulas. So there's your title. We're going to start right into formulas. So we're going to do our step-by-step directions for formulas. Step number 1 is very similar to what we've been doing. It is write the cation symbol. Cation has what charge? Cation is always positive, right? So we're going to write the cation symbol with charge. Write the cation symbol with charge. Write the cation symbol with the charge. That sounds familiar. Yes? Right? No? This is what we've been doing, right? Yeah. Mg2 plus, Fe2 plus. There's a little bit, something a little bit different, okay? So, our three kind of subs for this. Where could my cation come from? My cation could come from group number 1. So I could have a 1 with a back. It could come from the transition metals, right? So I could have a 2 with a back.
What's a back?
Oh, good question. Look at the back of your periodic table. Those are your polyatomic ions. All right? Those are your polyatomic ions. This is no different than what we've been doing. They're just groups now. They're just groups with the charge instead of single atoms with the charge. And then the good thing is they're all on there. You don't have to memorize them, right? So my cation could be from the periodic table, a group 1. It could be a group 2, or NH4 plus 1. NH4 plus 1, which is ammonium, is the only group on the back that can be a cation. Why is ammonium, so look at the back, it's alphabetical, all right? Why is ammonium the only group on the back that can be a cation? It's the only group on the back that has a positive charge. It's the only group on the back that has a positive charge. Step 2. Write anion group formula, because now it's more than one thing, with charge from the back. So this is coming from the back of the periodic table. So that means I have a cation with a positive charge. I have an anion with a negative charge. What's step 3 going to be? Step 3 is crisscross. If what? If not a perfect match. You got it. If not a perfect match. What? Group. Crisscross if not a perfect match. Where it doesn't say goop. That says group.
No, it says gloop.
Behind anion.
Group. That's an R. You can't tell.
Yes,
Group. You didn't write gloop, did you?
I knew what you meant.
So I've crisscrossed. Number 4 is reduce. reuse, recycle, reduce if needed. And step 5 is probably the most important step. This is the new part, all right? Step 5, use parentheses if subscript on the group is not a ghost 1. If the subscript on the group is not a ghost 1. What am I talking about here? Well, let me give you an example, all right? Let me give you an example. The year is 2040. How old are you?
I don't know. I'm old. 33.
32.
Yeah, you're a little bit younger than I am now, right? So you're old. You might have a family, you might have a couple kids, and you pull up to McDonald's, all right? You pull up to McDonald's, and you have 2 kids, okay? They're twins, actually. All right, they're twins. Twin girls. Twin girls. So envision this. If this is like me predicting your future, get back with me in 2040, okay? Because I want to know if this is a correct prediction. You pull up to McDonald's, and all you say is, I would like 2 Happy Meals. Biggest mistake of your life, all right? Because you have to order 2, you need to say, if you want to get it correct, you need to say, I want 2 Happy Meals, parentheses. That is how you actually want to order. Here's why. Stay with me, stay with me. Stay with me. So, if you order 2 Happy Meals, it's possible that you could get for your 2 Happy Meals 2 burgers, and we're getting nuggets, let's be serious. All right, this is all fake meat by this point. We don't even have meat at this point, which is all like lab-grown meat. So 2 lab-grown meat chicken nuggets, 2 fries, 2 fruit. Okay, let's be serious, we get the extra fries. We don't get the fruit with our Happy Meal, all right? 2 juices, but only 1 toy. World War IV has just begun. World War III already happened. We already did that with Russia, okay? That's about to start. Anyways, World War IV has just begun because one of your children has a toy and one of yours doesn't because you didn't keep the Happy Meal together. Vital. You cannot change the contents of a Happy Meal. The Happy Meals we're going to be talking about in chemistry are these groups on the back. You cannot change a Happy Meal, all right? Do not change a Happy Meal, and I'm going to show you how important this is. So let's do an example. We're going to write the formula of the following. Magnesium pyrophosphate. Sounds fancy, but it's not that hard. So I have magnesium pyrophosphate. Magnesium pyrophosphate. The steps that I have been giving you are so good, all right? If you follow the steps, you will be successful. What is step 1? Okay, so what is Mg? Yeah, magnesium is Mg. What is the charge for magnesium?
+2.
You're starting to remember these, +2. Step 2 says, write the anion group formula for the charge from the back. So look up pyrophosphate. It's in alphabetical order. What is this formula for pyrophosphate? P2O7 with a 4 minus. 4 minus. Is this a perfect match? No. So what do I have to do? Crisscross. So the 2 is going to come down here. Follow the steps in order. The 4 is going to come down here. So that gives me Mg4 P2O72.
Oh.
Do you see it? I did not keep the Happy Meal together. I do not want 2 fries and 72 nuggets.
Well,
I want 2 of the whole Happy Meal. So when I crisscross down, this is not a ghost 1, agreed? Yeah. So whenever there's a number by the group, you have to put a parentheses around it to keep the happy meal together. Because I want 2 of the whole thing. Because ideally I'm trying to balance out the charges, right? Yes? What is 2 times -4? -8. What is 4 times +2? +8. That's why you have to keep the happy meal together. But am I done?
No.
It says reduce if needed. So this is going to actually reduce to Mg2P2O7. Do I need the Roman numeral anymore? No, I don't.
Wait, what'd you do with the 4?
4 divided by 2 is 2. 2 divided by 2 is 1. I divided them both by 2 because I can. Now, people ask me, Mr. Heller, can I keep the parentheses around here just so I don't forget? Sure. I don't care if you add a parentheses when you don't need it. It's a little bit repetitive, but if you want to just keep parentheses around happy meals at all times, I'm good with that. Okay?
So these things on the back always need parentheses around them?
They don't have to. They only need it if the number's not a 1, right? But if you want to just automatically put a parentheses around it, I'm cool with that. Let's try another one. Try this one, copper 2 chromate. This is copper 2 chromate. Copper 2 chromate. What is the symbol for copper? Cu. What is the charge of copper? It's here in the Roman numeral, right? Yes. We're combining what we've been doing the last 2 days. So this is a 2 plus from the Roman numeral. Look up chromate.
CrO4.
CrO4 with a 2 minus. Is that a perfect match?
Yes.
Yep. So this is just going to be what?
CuCr.
CuCrO4. CuCrO4.
Oh, because we reduced it.
Well, it's the perfect match, so we reduced them, right? Technically, I would have crisscrossed them, but I don't even need to do that. It could be 2 and a 2 and a reduce. Try this one. Rubidium carbonate. Rubidium carbonate. Try that one on your own. Actually, just try that one. Rubidium carbonate. Symbol for rubidium is Rb. Charge is +1. What is carbonate?
CO3 minus 2.
CO3, 2 minus. Is that a perfect match? No. So I'm going to crisscross. 2 is going to come here. 1's going to come here. Going to give me Rb2CO3. Is that what you guys said?
Yeah.
Yeah? Okay, one more. Then we'll go to the opposite way. Let's do ammonium sulfite.
Isn't that the stuff you sniff before you listen?
Ammonium is the stuff that you sniff, yep. It's actually ammonia, a little different, but ammonium sulfite. Try this one on your own.
Do you have any more of these?
What? Periodic tables?
No, I have a periodic table. I think polyatomic.
Why is yours not on there?
Because I lost that.
Oh, yeah, you're definitely going to want that. Ammonium sulfite. I would look at step 1 of your notes. Look at step 1 of your notes.
My periodic table disappeared. I have no idea where it went.
Oh my
gosh.
5 minutes ago.
5 minutes ago?
Yeah.
It's right there.
Oh, I had it flipped over.
True.
Sulfite.
I thought it was a different picture.
Braden, what'd you write down for ammonium?
Ammonium, we got NH4.
NH4 1 plus. That's the only group that can be a first name. What'd you write down for sulfite?
SO3, 2.
SO3 2 minus. Love it. Is that a perfect match? Did you crisscross?
Yes.
Okay. So we crisscross. 1 here, 2 here. Did you end up with NH4?
Parentheses.
Yep. This you're going to end up with N. Get off of that. H4 parentheses 2 SO3.
Almost. I put parentheses around SO3.
Ah, I don't need a parentheses around SO3.
Is it wrong to put it on SO3?
No, if you put NH4 2 parentheses SO3, as long as you have a parentheses around the first thing, because it can't be NH42. That's something different.
So I understand what, how to do this and everything.
Yes,
But what the heck are we doing? What do these mean?
we're making compounds.
Oh, so it's just like,
Because we have to understand how to make a compound, because next chapter we're going to actually react compounds together and do chemical equations. Yes. So we're actually going to blow something up, actually do the 5 reactions. Yes.
okay.
So this is the basis of what we have to do for next chapter.
Does everyone get to blow something up, or is it just you?
You'll get to. Everyone will get to. All right, so that was formulas. So let's do some names. So for the names, you basically just ask yourself a question. So the question is, do you know the charge, right, of the cation? Do you know the charge of the cation? There's 2 possible answers to that.
Yes or no?
Yes or no? If the answer is yes, then just name it. Just name it. If the answer is no, what am I going to have to do if I don't know the charge of the cation? How do I figure it out?
You reverse.
You got to do the uncrisscross from yesterday. All right? If the answer is no, you've got to do the uncrisscross. Uncrisscross and add a Roman numeral. Uncrisscross and add a Roman numeral. So, here we go. Example. So if we had something like this, AuPO4. And I said, write the name of this. Okay? AuPO4. Ask yourself, do you know the charge of gold?
Yeah.
No. Which means I have to do what? Uncrisscross. Be careful here. Can I uncrisscross this 4 up to gold?
No.
Why?
Because you can't eat.
It's part of the Happy Meal. All right? What am I going to actually uncrisscross up to gold? A 1. So this is a 1 plus. This is a 1 minus. After I uncrisscross, what do I have to check? The charge. Is PO4 a minus 1?
No.
No, what is it?
-3.
So I have to multiply it by 3. How'd you find what?
The charge of.
PO4?
You just go to PO4.
Yep, you just go to PO4. If I multiply this by 3, I have to multiply gold by 3. So the name is gold 3 phosphate. Gold 3 phosphate. Gold 3 phosphate. What about the name of this one? I don't know. BE CO3. BeCO3. Ask yourself, do you know the charge of beryllium? Beryllium is always a +2. So I'm just going to name it. What's my first name? Beryllium. What's my last name? Look up CO3. It's in group 2, has a +2 written above it. Right? Beryllium is right here, has a +2 written above it. All those, we always know those charges.
So how do we not, oh, it's golden.
Transition metals, right. So this is literally just beryllium carbonate. So if you know the charge, you just write first name, last name. If you don't know the charge, you've got to uncrisscross. That's it. Tonight, your homework is 2 things. 2 things. Thing number 1 is this half sheet. This has like all transition metals on it. So do this. And thing number 2 is only this side. All right? Only the front side where it says naming compounds with polyatomic ions. So these. The back then, whatever that is. The back. So the part that says naming compounds with polyatomic ions. So the half sheet and this. Practice. Tomorrow we'll go through all of those.